While shoveling snow, Chewbacca moves its arms 0.5 meters to lift 50 newtons of snow, a height of 1.5 meters. How much force did it take to lift the snow? Well, once again, I'm given two distances, and so he had to move his arms, so that his displacement in equals 0.5 meters, and he ended up moving the snow displacement out 1.5 meters, and then he ended up applying a force in of 50 newtons. Well, first we need to go figure out a mechanical advantage, but the question is which one. Now we have two displacements, so I'm going to go figure out ideal. And then mechanical advantage. In the end, I'm going to want to know how much Now I need to be a little bit careful. When it talks about I lift 50 newtons of snow, that means that there's 50 newtons here. And so that is a force out equals 50 newtons. The question asks, how much force did Chewbacca need to apply? That's in newtons. And in order to do that, the first thing I need is mechanical advantage. Now, since I have two displacements, I'm going to go ideal. And that equals displacement in divided by displacement out. And so my displacement in is 0.5 divided by my displacement out, which was 1.5. And now this is a little interesting because I get a 1 to 3 ratio, or a 1 to 3 ratio. This is interesting because this is a displacement advantage. Chewbacca doesn't need to move his hands very much, but the shovel moves a lot. So if Chewbacca has an advantage when it comes to displacement, it means he has a disadvantage when it comes to forces. And so I'm going to use mechanical advantage real, which I know equals 1 over 3 to equal force out, which I'm told is 50 newtons of force. But my question is, how much force does Chewbacca need to apply? Force in. If I cross multiply, I find that the force in equals 150 newtons of force. In other words, Chewbacca needs to apply more force to the end of the shovel than the actual snow weighs. But here's the thing, he moves it over a much greater distance.